It's your friendly math tutor, Miss C here, and today we're solving systems of equations. I have a system here, and my first step is to decide, do I use substitution or elimination? So when I look at these equations, if I use substitution, I know I'm going to have to get either one of the equations isolated for x or y, and the numbers are just not great. I'm going to end up with fractions. I love fractions. I find that most students do not. So I am going to use the elimination method instead. So we are using elimination for this problem. And then I need to decide what variable I'm going to eliminate. I noticed that 3 and 2 do not go into each other easily. I know that 4 is a multiple of 8. So that would be the easiest variable to eliminate. So I'm going to eliminate y. So that's what I'm going to do as my next step. And the way I'm going to eliminate y is I'm going to look at if I have 8y in the first equation, to eliminate it, I need 8y to add to another number so that I get 0. So I know that to do that, I need this 4y to equal negative 8. So I need to add 8y to its inverse, which is negative 8. So to get 4y to equal negative 8, I need to multiply by negative 2. Now, I can't just multiply 4y by negative 2 because if I were to do that, I would change the entire value of the equation. And what I really need to do is write an equation that has the same value but looks different. So to do that, I'm going to multiply this whole equation by negative 2. So I'm going to rewrite my top equation here. So I made no changes to that. And now I'm going to distribute negative 2 to every term in this bottom equation. Okay, and when I do that, I get this system right here. So now let's make sure that I eliminated y correctly. So I have 8y minus 8y, that equals 0. Those are eliminated. So now all I'm going to do is I'm going to combine my like terms. So I have 3x minus 4y, that gives me negative x, equals 11 minus 14. That minus sign is not very big, is it? So there we go. 11 minus 14 is negative 3. I need x to be positive, not negative. So I need to actually take one more step and multiply this entire equation by negative 1. Or you could divide the equation by negative 1. It's the same thing. So that x becomes positive. And when I do that, when I distribute that negative 1 throughout or divide the whole equation by negative 1, I get a value for x that is negative 3. Or that is positive 3. Sorry about that. Positive 3. Now, I need to find y. So I need to pick either my top equation or my second equation to substitute 3 in everywhere I see x. I'm going to pick the second equation only because the values are a little smaller, although it doesn't really matter. And everywhere I see x, I'm going to be plugging in 3. So you can see I did that substitution in green. And now I'm just going to simplify the left side of the equation, and then I'm going to solve. So 2 times 3 is 6, plus 4y equals 7. And now I'm going to follow the order of operations to solve this. So I'm going to work PEMDAS backwards because I am moving things across the equal sign. So the addition and subtraction I have is this 6 because I'm trying to get y by itself. So I'm subtracting 6 from both sides. When I do that, I get 4y equals, pardon me, 1. And now I'm going to do any multiplication or division. 4 is being multiplied by y, so I'm going to do the opposite of multiplication, which is division, and y equals 1/4. So my solution is 3 and 1/4, which we could write as a coordinate pair. And what this answer is telling us is the point of intersection of these two lines. So we know the point that these two lines meet is at 3 and 1/4. If I were you, I would plug this back in to both equations. The first one for 3, the first one, 3 for x and 1/4 for y in both equations, and make sure that you get out 11 in the first equation and 7 in the second equation, just to double check that your answer is right. I've already done that, so I'm not going to show you how to do that. Thanks for joining me. Make sure to subscribe for more videos. Till next time, remember, you've got this.